In this lesson, we're going to talk about simplifying radical expressions. So in algebra, we do simplifying a lot. And all that simplifying means is if we have an expression like x plus x, we like to write that in a different form that is equivalent, like 3x. So x plus x, that represents a quantity, but it's a whole lot simpler to write 3x. So simplifying just means writing things in different ways, but with the same value. Okay, so let's think about this. Let's say we want to multiply the square root of 25 times the square root of 4. Well, we could do that two ways. Maybe we want to square root first. Square root of 25 is 5. The square root of 4 is 2. And 5 times 2 is 10. Okay, that's one way we could go. Can you think of another way we might do this? What if we have the square root of 25 times the square root of 4? Well, maybe you might want to multiply those first. Let's just try it. Square root of 25 times 4 is 100. So that's the square root of 100. Well, what's the square root of 100? Remember, square root means what number squared equals 100? And the answer is 10. So we get the same answer. So the moral of the story is this. If we have two square roots that are being multiplied, we can either square root them first and then multiply, or we could put them together under one square root, meaning just multiply the two numbers, and we get the same answer. And this is always true. This is what we call a radical product rule. And it's not just for square roots. It can actually be for any index. So if we have the nth root of a times the nth root of b, well, that's the same as the nth root of a times b. In other words, we can take these two numbers, a and b, and we can multiply them so that we end up with one square root and the two numbers multiplied underneath. Okay? So, let's see how that works. So we got the square root of 2 times the square root of 5. Well, that's just going to be worth the square root of 2 times 5. We can put them under one square root, and that is the square root of 10. So that is simplified right there, okay? All right. So we've got, how about this? What if we got, binomials? Well, we've got x plus 5 and x minus 5. Those really need to be in parentheses if we're going to do this right. So we've got x plus 5 times x minus 5. Okay, now we haven't seen binomials yet in this course, or in this chapter at least. So how do we multiply those? Well, you remember we need to distribute. This is being multiplied here. So we've got to distribute the x times the x and the x times the negative 5. Does that look familiar? Hopefully from previously algebra experience there. We got x times x squared. We've got x times 5. That's going to be, actually it's a negative 5. So negative 5x. Now we got to take this 5 here and multiply it times that x. That gives us a positive 5x. And then we've got this positive 5 times this negative 5. And that's going to be negative 25. 5 times 5 is 25, but we got a positive times a negative. And we can simplify that a little further. We've got negative 5 times a positive 5, and that is, or negative 5 plus, negative 5x plus 5x, that is 0. Those cancel. Okay, those are gone. And so we have x squared minus 25. Now be careful. You cannot go any further. Are you tempted to square root this and square root this? All right. We're all tempted like that, all right? But don't do it because of this minus. Because if this is add or subtract, you can't just square root that and square root that. We have to leave that alone, okay? Well, how about this? Cube root. Oh, okay. Well, it also works for cube roots here. And we have 2 times negative 4. And we know what 2 times negative 4 is. That is negative 8. All right, and so we have cube. Oh, can we take the cube root of a negative number? We sure can. It's negative 2. Because remember, we can cube root negative numbers, but you can't square root negative numbers. All right. So again, we can put them together, and then if we can simplify them, go for it. Ooh, how about a fifth root? All right. So we have a fifth root, and we're going to multiply those under one radical. Now, this step that I'm writing here, we could probably skip in just a moment. All right, but that's really what's going on. Okay, but you could probably skip what I just wrote there and go right to this. Well, let's multiply. Now, careful, we're multiplying 3 times 2. 3 times 2 is 6. Now, what else are we multiplying? That's an x to the first, right? A little invisible 1 right here. What is x to the first times x to the fourth? Talked a little bit about that in the last lesson. X to the 1 times x to the fourth. We have a power rule. We're going to add those exponents, right? That's x to the fifth. And if it helps, write that out. That's x times, and we have this x times x times x times x. We have 1x times 4 x's, or all multiplied, that's x to the fifth. Okay, enough of that. So we got 6x to the fifth. Add those exponents. Ooh, can we simplify this any further now? Well, we don't know what the fifth root of 6 is, but we do know what the fifth root of x to the fifth. So here's something that we're going to be working on a whole lot. Okay, we can break this up into 2 square roots. We have the square root of 6 and the square root of x to the fifth. Now notice, what did I just do there? Okay, I just used this rule backwards. I took 1 square root and I broke it into 2 square roots. Why would I want to do that? Well, because I can deal with this, but I can't deal with this. I don't know what the fifth root of 6 is. You can use your calculator and find it. It's a decimal number, but I don't know what it is. But remember that these are inverse operations. The fifth root of x to the fifth, those are opposites. Okay, they cancel each other out, and that just leaves x, if you want x to the first, or just x. Okay, so x times the fifth root of 6 is the most simplified version. Okay, so that's the radical product rule. Next, we'll see how we can use that to simplify square roots.